Good morning, students. Today we will discuss using algebraic expressions, formulas, and rules. Say first one, perimeter formulas. First, the perimeter of an equilateral triangle equal to 3 into the length of its sides. If we denote the length of the side of equilateral triangle by L, then the perimeter of the equilateral triangle equal to 3L. The second point, similarly, the perimeter of a square equal to 4L, where L equal to the length of side of the square. Third point, perimeter of a regular pentagon. It is equivalent to 5L, where L equal to the length of sides of pentagon and so on. Now area formula. First, if you denote the length of a square by L, then the area of the square equal to L square. Second point, if you denote the length of rectangle by L and its breadth by B, then the area of the rectangle equal to L into B equal to LB. Third, similarly, if B stands for the base and H the height of triangle, then the area of the triangle equal to B into H upon 2, or we can write it as BH upon 2. Now rules for number patterns. Study the following statements. First, if a natural number is denoted by n, its successor is n plus 1. We can check this for any natural number. For example, if n equal to 10, its successor is n plus 1 equal to 11, which is known. Now second point, if a natural number is denoted by n, then 2n is an even number and 2n plus 1 an odd number. Let us check it for any number, say 15. 2n equal to 2 multiplied by n. Put the value of n as 15. It can be written as 2 into 15, that is 30, is indeed an even number. And 2n plus 1, it can be written as 2 into 15 plus 1. Put the value of n as 15. You will get 2 into 15, 30 plus 1. That is 31, is indeed an odd number. Now observe the pattern in the figure 12.1. This is your figure 12.1. It consists of an repetition of shapes, that is square. In making a square, how many segments are required? 4. If a shape square is made from 4 line segments, as you see, for one shape you need 4 segments, for 2 shapes 7, for 3 10, and so on. If n is the number of shapes, then number of segments required to form n shapes is given by 3n plus 1. You may verify this by taking n equal to 1, 2, 3, 4, and so on. For example, if the number of letters formed is 3, then the number of line segments required is 3 into 3 plus 1, that is 9 plus 1, that is 10, as seen from the figure. Some more number patterns. Let us now look at another pattern of the numbers, this time without any drawing to help us. That is 3, 6, 9, 12, and so on up to 3n. Here, the numbers are such that they are multiples of 3, arranged in increasing order, beginning with 3. The term which occurs at nth position is given by the expression 3n. You can easily find the term which occurs in 10th position, which is 3 into 10, that is 30. 100th position, which is 3 into 100, that is 300, and so on. Now pattern in geometry. What is the number of diagonals we can draw one vertex of an quadrilateral? Check it. It is 1. From one vertex of the pentagon, check it. It is 2. See, ABCD is a quadrilateral. Here we have drawn one diagonal, that is AC. Now ABCDE is a pentagon. How many diagonals we can make? 2. That is AC and AD. Here this is an hexagon. ABCDEF is an hexagon. How many diagonals we can make it? 3. That is AC, AD and AE. So from one vertex of the hexagon, it is 3. The number of diagonals we can draw from one vertex of the polygon of n sides is n minus 3. Check it for heptagon. Heptagon has 7 sides, and octagon, which has 8 sides. By drawing figures, what is the number of triangles if it has 3 sides? Triangle means it has 3 sides. Observe that the diagonal drawn from any one vertex divide the polygon in as many non-overlapping triangles as the number of diagonals that can be drawn from the vertex plus 1.